All right, let's talk about shapes, but forget everything you learned in a boring geometry class. Today, we're going to meet a powerful family, a squad of figures that, I'm not kidding, literally build the world around us. So let's dive right in.
Okay, let's kick things off with a little riddle. I want you to think about a diamond, a brick, and a kite. I mean, they seem totally different, right? But I promise you, they all share a secret family identity.
And the answer is, they're all quadrilaterals. Think of this as the family name, and it kind of gives the whole game away. Quadri means four, and lateral means sides. So a quadrilateral is just any closed shape with four straight sides. That's it. Simple, right? But this is the foundation for everything to come. Now, every family has rules, and the quadrilateral clan has one huge, unbreakable law. It doesn't matter what the shape looks like, if you stretch it or squish it or tilt it, the four angles on the inside will always, and I mean always, add up to exactly 360 degrees. It's the one thing that connects every single member, no exceptions. So, like any big family, this one's got a few different branches, and the whole family tree really splits apart based on just one critical feature: how it uses parallel sides. This is where we meet the three main clans.
And here's the breakdown. First, you've got the parallelograms. These are the overachievers, with two pairs of parallel sides. Then you have the trapeziums, which only have one pair. And finally, you've got the kites, which, they're kind of doing their own thing. They're defined by having two pairs of equal sides that are right next to each other, not opposite. That one little difference changes everything.
Okay, so now we're going to zoom in on the most famous, most influential branch of the whole family, the parallelogram clan. Seriously, these are the A-listers, the shapes you see absolutely everywhere, and each one has its own special superpower.
So let's start with the OG, the one that gives the clan its name, the parallelogram. This is your classic, dependable foundation. Its powers are pretty straightforward. Its opposite sides are parallel and equal, its opposite angles are equal, and its diagonals, the lines that cut across the middle, slice each other exactly in half. From there, we get the rectangle, who I like to call the builder. It's super orderly. So it inherits all those basic parallelogram traits, but then it adds its own special power. All of its corners are perfect 90-degree angles. And that one change gives it a cool bonus feature. Its diagonals are now exactly the same length. Next up is the stylish one, the jewel of the family, the rhombus. Now, just like the rectangle, it starts with all the basic parallelogram DNA, but its special power is different. Instead of perfect angles, it gets perfect sides. All four sides are equal, and that gives it a totally different bonus. Its diagonals cross each other at a perfect 90-degree angle.
Okay, so think about this. We have the builder with its perfect 90-degree angles, and we have the jewel with its perfectly equal sides. So what do you think happens if a shape could get the best powers from both of them?
Well, you get the king of the castle, the square. It takes the 90-degree angles from its rectangle ancestry and the equal sides from its rhombus ancestry. It's not really a new shape, it's just the perfect combination of the others. It literally has every single power we've talked about so far.
All right, now that we've met the main members of the parallelogram clan, let's put them all side by side. This is where we can really decode their powers and see who does what. It's like looking at the back of a trading card.
But before we look at the chart, here's a little pop quiz for you. Out of the four shapes we just talked about, parallelogram, rectangle, rhombus, and square, how many of them have diagonals that are perfectly equal in length? Go on, take a guess. The answer is just two. And this chart shows you exactly why. Check out that row for diagonals equal. See? Only the rectangle and the square get that check mark. This table is basically the ultimate cheat sheet. You can clearly see how the square just inherits all the best powers from both the rectangle and the rhombus. All right, let's switch gears and get practical. Think of this next part as your field guide, a couple of quick tricks and formulas you can use to identify and measure these shapes when you see them out in the wild. So, this here is how you measure the space each shape takes up, its area. The formulas for the square and rectangle are super simple, ones you probably know. But look at the others. They use different parts, like the height or the length of their diagonals. It just goes to show how unique each member of the family really is.
And now for my favorite part, a little secret trick. Forget the sides, forget the angles. You can figure out which parallelogram you're looking at just by checking its diagonals. Seriously, if they cut each other in half, it's at least a parallelogram. If they're also equal in length, boom, it's a rectangle.
If instead they cross at a perfect 90-degree angle, it's a rhombus. And if they do everything, they bisect, they're equal, and they cross at 90 degrees, you found the king. It's a square. This all leads us to that classic saying that probably confused us all in school, but now it should make perfect sense. All squares are rectangles, but not all rectangles are squares. See, a square is just a special type of rectangle, one that went the extra mile and made its sides equal too. But a regular old rectangle doesn't have to do that, so it doesn't get to be called a square. It's all about that family inheritance. Which really brings us to the main takeaway here. The square is, without a doubt, the king of the quadrilaterals. It's got the perfect angles of a rectangle, the equal sides of a rhombus, and the parallel sides of a parallelogram. It's the most specialized, the most symmetrical, it's just got it all.
So, there you have it. You've officially met the squad. Now the fun part begins. The next time you're just looking around at a window, a book, the tiles on the floor, even a street sign, ask yourself, which member of the shape squad am I looking at? Because once you start looking, you'll see them absolutely everywhere. So, which quadrilateral shapes your world?